practice a couple of these together today. Make sure we kind of have a system, because it might look a little overwhelming at first, but it's really not that complicated. There's just a few things we need to do to figure out if Sean can add 10% of the weight to his boxcar, his Pinewood Derby car, right? Okay, somebody still has music playing. I can hear it. So everybody needs to turn their AirPods off, turn their music off, AirPods out. Thank you. Okay. So we have some information here, right? We know how much the car weighs. Why would someone want to increase the weight of a derby car? How's that going to help them? Maggie?
To get it to go faster.
Right. The heavier it is, right? Doesn't it start up at like a ramp and they drop it and it has that momentum, right? Some physics. Okay. So we're trying to figure out how can we make that go faster. He wants to increase the weight. But there's a rule. What's the rule that he has to follow? Anna? Has to be under 5 ounces. Otherwise, he cannot use his derby car. Okay, no cheaters. All right. So we've broken it down into steps. Okay. Ultimately, the steps wouldn't be here for you. You would be the one figuring out what you should do first, second, third, and so on. But at the beginning of this, just to kind of give you guys an idea of how to start these, we have some steps for you created. So the first thing we're going to do is determine the weight of the car in ounces, which is nice because we have a conversion here. What are we going to do to figure out? What are we going to create? What have we been creating? Where we have something equals something and we label it and it's all organized. And
Conversion.
a conversion, but what are we going to use to convert? What is it called? A
Fraction. Preparation.
Proportion?
Oh.
Yeah?
You do that.
Yeah, we're Monday morning. Okay. So we have grams and ounces. Remember, we label these so that we can keep them organized.
How do we know which one goes on the top?
So do you see how it says 1 gram equals this many ounces?
Yes.
So where I have the conversion of a 1, that's going to go on the top. So 1 gram equals 0.04 ounces. We know that the car weighs 120 grams. We're trying to find out how many ounces is that. Yep, so we have our calculators. We're going to do our loopsy-loops here.
Airplanes.
X equals 4.8. And that's ounces. And then we're going to help ourselves out, but we're going to label that this is the current weight of the car. Right? So as you go along, if you kind of like give yourself little reminders of what this actually represents, that will help you when you're going back and putting it all together. Now we need to figure out the new weight. He's going to increase the weight by 10%. So what kind of math thing do we need to do to increase the weight by 10%? Yes, sir?
10% of 120.
You're close. Not 120, because we're going to use, now we have it in ounces, so we're going to find 10% of 4.8 ounces, right? Because we have to know, based on the rules, the weight in ounces. So now that we've converted to ounces, we're going to stick to ounces. Okay, now, Aiden, if you had done everything in grams and then the last step was to convert to ounces, that's fine. But we're going to stick with what we've already kind of started here. So we're going to use that part to whole because we're going to try to find 10%. Remember, we did all these percents last week. We don't know what 10% will be, but we know that right now it's 4.8 ounces. So we're going to do our cross loop-de-loops. We're going to get 100x equals 48. Divide by 100 here. X equals 4.8. Sorry, 0.48. What am I doing? 0.48. What am I going to do with that number to find the new weight of his derby car? I'm going to add it, right? Just like if I was adding a tip or finding tax of something, right? I add that percentage because he's an additional 10%. He's increasing it. So I'm going to take the 4.8 is the current weight of the car plus 0.48, which is the added weight of the car. I'm going to sneak a little zero placeholder in there so that I can line up my decimals. So the new weight that he wants to make his derby car is 5.28 ounces. No bueno. Why? It's over 5. So no, he cannot add 10% weight to the car. Too heavy. Right? So if 10% was 0.48, what would 5% be? 0.24, just cut it in half, right? Could he add 5% of the weight? No, it's still too heavy. So he's got to do like 3% of the weight, which, I mean, is it even worth it at that point? No. That'd be hard to do. Okay, let's move on to our next scenario. Da-da-da-da. We have a Spartan race. You guys know what a Spartan race is? It's kind of like a really intense obstacle course for people who work out a lot, are in shape, and have nothing better to do on the weekends than crawl around in mud and climb walls. And
That would be so fun.
it's not for me, but people do like it. Okay, take a couple seconds, read through this whole page, and then we will talk about it. That's one of the first things you have to do is read through the page. Don't just jump into it. You need to read the whole question to figure out what are they asking you to do. Okay, so what do we have here? What information are we given? we know? I see some pencils moving. What are you guys working on? Tell me what you're doing. What do we know? How did you get started? You weren't supposed to start on it, but it's okay. Some of you are in it. So what do we do here? What's going to be our first thing? Let me just like stare at you guys.
Yes.
Addison, thank you.
You have to turn 2.5 hours into minutes.
Perfect. We're going to convert, right? Because we need to know their total time in minutes. So we're just going to use minutes for all of these so we're consistent. So the first thing is convert Abe and David's time into minutes, right? We know the conversion here. So we have hour and minutes. We're going to do Abe over here. So 1 hour is 60 minutes. We know that it took him 2.5 hours, and we don't know how many minutes that is. So when we do our cross multiplying, we get x equals 150. That is his time. You can do the same thing for David, right? We've got hours and minutes. We have 3.25 hours. How many minutes is that? We're going to do our cross multiplying here. Who already has that done, the math? What is it, Gianna?
Actually, I don't really know. I think it's
It is 195, yeah.
Gianna.
Yep. You just multiply. There's nothing to divide by because x, we would have 1x, and divide by 1, you get the same number, right? So there you go. We have 2 of the times, right? Easy peasy. We're going to use Abe's time to find Brandon's time. How do we know? What's the information they give us about Brandon's time? What do they tell us?
15% of Abe's time.
Yeah, an additional, right? So we're going to have to find out what 15% of Abe's time is, and then what am I going to do with that? Add it. Yes, I'm going to add it. It's like a tip or tax. Okay, so we have part over whole. So we have 15% equals, we don't know what it is, but it's out of 150. We're trying to find what is 15%. So what is the part out of the whole? So I do some cross multiplying. Divide by 100. That tells us what 15% is of Abe's time. What am I going to do with that 22.5 minutes? Add it to Abe's time, right? So 150 plus 22.5. I make sure I line up my decimals when I'm adding. So Brandon's time is 172 minutes and 50 seconds. Or 172.5 minutes, which is 172 minutes and 30 seconds. Are you guys filling in this table up here? Organizing your information? Good, good. How about Cecil's time? Yes, Carmen.
It says to round it, so do we round
Well, it says to the nearest tenth of a minute, so we'll just take the 0.5, right? But if it was to the nearest minute, then yes, it would be 173 minutes. Great question. All right, so now I need to use Brandon's time to find Cecil's time. Somebody tell me, how fast is Cecil? How fast did he complete the race? Aiden?
I haven't done it fully. I didn't realize what you wanted.
That's okay. Tell me what math you did to get there.
80% of 172.5
Yeah.
to get 138.
Yeah, so you have to find 80% of that number because his race is 80%. We're not going to do anything with that then. That's just our answer, right? Remember when we first started out and it was like find 4% of 91. And then that's where we stopped, right? So we have the part, whole, 80%. We don't know the part answer. That's going to be Cecil's time, but the whole time would be 172.5 because that is Brandon's time. It is. It's 13,800. More obvious here. Oh. So we have Cecil's time of 138. And my last step, I just need to figure out how long it took all four of them to finish. What am I going to do with all those minutes? Add them. Make sure you label it minutes. Hours would be way too long. Seconds would be way too fast. I need to know you know that that's minutes. Okay, when you're done, put this in your jam behind the conversion practice we just did. We will continue this tomorrow.